Now we're going to start working our way into how to find all of the zeros of a polynomial that is too big for us to either factor or use the quadratic formula on. To get there, we're going to have to review a couple old skills like how to use long division. Now, before I do an example with polynomials, I thought it would be worthwhile to quickly do one with numbers just as a quick refresher, since you probably haven't done this in a while. The steps that we use are actually pretty identical, but instead of applying something to a digit and a number, we'll be applying it to a term in the polynomial like 3x squared and then 3x and 6, etc. So the way this starts off, we identify the number that we're dividing, which is 298 in this case, that goes inside the box, and then we identify what we're dividing it by, which is 14. Now we start off by looking at the very first digit inside of the division. 14 does not go into 2. There's nothing I can multiply it by to make it very close to 2, but not bigger than that. So I instead include the next digit at the same time. So now I'm looking at 29. Well, 14 times 2 is very close to 29 without being too big. So I write the 2 on top, that's what I chose to multiply it by, and then the multiplication goes here underneath. Next step that's important is to remember that we are subtracting these numbers. And I'm subtracting the 9 minus the 8, and I'm subtracting the 2 minus the 2. So remember, this will be important when we're considering these as different terms instead of digits. Once you perform that subtraction, you will bring the next digit down and repeat this process. So now I would say, what can I multiply 14 by? That will be really close to 18, but not bigger than. So in this case, that would just be times 1. And then again, we would be subtracting all of these digits. So 8 minus 4 is 4, and we're done at that point. Since we can't do this division anymore, we've already used all of the digits inside of the division. That leftover 4 is what we call the remainder. So my answer is 21 with a remainder of 4. And we'll talk about how to write your answers for polynomials in a second. One important note to make here is that when you are dividing polynomials, you have to make sure it's in standard form, which means that your exponents need to be in decreasing order. So start with the biggest exponent and count down. That applies to both the polynomial that'll be out front and the polynomial that's on the inside. The next important reminder is that if there are any missing terms, so maybe you see an x cubed in what you're dividing, but you don't see an x squared, and then you see an x to the first power. Well, if you don't see one of the exponents for x, then you need to fill in a missing 0 in that spot. And I'll show you that carefully on an example, but that again applies to your polynomial out front and your polynomial on the inside. So just remember what filling in missing zeros looks like, and I'll show you on an example in a moment. So here's our first example. We are being asked to divide 3x cubed plus 5x squared plus 8x plus 7 by 3x plus 2. So you can see I've already set up what my division will look like. And then our first step is to figure out what do we multiply this expression out front by to equal the first couple terms on the inside. Now, to narrow your attention, we actually only care about the first term on the inside and the first term on the outside. So what I like to do is I like to focus on just those two terms for a second. If I said, what is 3x cubed divided by 3x, so the first term on the inside and the first term on the outside, the answer to that is x squared. The 3's cancel and one of the x's cancels. That's how you figure out what to write on top. I'm ignoring everything else on the inside and everything else on the outside. We only use the first terms on the inside and the outside for this. So now I know x squared goes on top. And then our next step, after we write a number above the division, this term needs to be multiplied by everything out front of the division box. So I need to do x squared times 3x and x squared times 2. Make sure you are multiplying everything out front by the number you write on top, or the term you write on top. Now the next important thing to remind you, just like when we were doing this with numbers, is that we're actually subtracting these terms. So please don't just make sign flips on what you have here, otherwise it gets really confusing to follow what you got from multiplying and what you got from the sign flip. Please just put parentheses around everything you have here, and then write a minus sign out front of it. So now I'm working out 3x cubed minus 3x cubed, and that first term should always cancel out if you did this correctly. And then over here, I have 5x squared minus 2x squared. So I am distributing this negative through all of the terms. So 5 minus 2 is going to give me 3x squared. And then just like with the numbers, I brought down the next digit. Now I'm bringing down the next term of the polynomial. And I just need to repeat this process. So I focus on the first term on the inside, which is 3x squared this time. And the first term on the outside was 3x. So to figure out what goes on top, just work out 3x squared divided by 3x, which will be x in this case. So that's a positive x, so I'm going to write plus x. If it was a negative number, I would have written minus x. And then I need to take that number and distribute it through everything out front again. So I have x times 3x, and then I have x times 2. I need to remember that I am subtracting these terms, but instead of flipping the signs, it gets really hard to follow, so instead I'm just writing my minus out front to remind myself. And then 3x squared minus 3x squared cancels, so 8x minus 2x is 6x, and I have one last term to bring down. So now I have 6x plus 7. My first term on the inside is 6x, so if I write 6x over 3x and reduce this fraction, the answer will be 2. So that's my last number that goes on top. And if I distribute that, you get 6x plus 4. I'm actually subtracting those numbers, so the 6x's will cancel, and 7 minus 4 is 3. So that's going to be my remainder, 3. And then sometimes the way the question is phrased, they will say enter your quotient and your remainder separately. So the quotient is what we call this part right here. So whatever you have on top of the division box is your quotient, and then the remainder is the part that I labeled with an R. What's more common though, instead of entering those two answers separately, what's more common is they just ask you to write your answer as a polynomial, in which case you write your quotient here, and then for the remainder, we write plus whatever the remainder is. So in this case, I just have 3. And this is actually going to be a fraction. So your remainder is always over whatever you were originally dividing by. So I can either see that out in front of my box over here, or I can see it from the original question. I said to divide by 3x plus 2. So if you have a remainder, just put that number over what you're dividing by, and that creates a fraction. The rest of the quotient goes out front. Normally, no fraction attached to that part. So this is the most common way to write your answer. So now I wanted to show a more complicated example that has some of the missing 0 terms in it. So you'll notice for what we're dividing by, we have an x squared, but we do not have an x to the first power, and then we have a constant. So I only had one missing 0. It was the x to the first power piece. And then for what we're dividing, we started off with an x to the fourth, we have x to the third, we have x squared. So I'm missing 2 terms. I'm missing x to the first power, and I'm missing the constant. You don't really have to write the x here. I'm just doing it to make it easier to keep track of which terms we're missing, because 0 times anything is 0 anyways. But this way it was easier for me to remember that I'm missing not only the x to the first power, but also the number that doesn't have an x at all. Once you get the missing zeros filled in, now it's just repeating the same process we were doing before. So the first term on the inside is 27 x to the fourth. And we are only going to look at the first term on the outside, which is 3x squared. So if you reduce this fraction, well, 27 over 3 is equal to 9, and x to the fourth over x squared is equal to x squared. So I only looked at the first terms, and then that simplified fraction I just got is what I write on top. But then we need to distribute it by all 3 terms out front. However many terms you have out front, they all have to be multiplied by the number you wrote on top. So 9 times 3 is 27. X squared times x squared is x to the fourth. And then for the next term, I'm multiplying by 0. So this term is just going to be a 0 anyways. You can put the x cubed on there if you want, just to make it more clear which terms are being added together, but it's actually canceled out essentially. And then 9x squared times 1 is 9x squared. So to avoid confusing myself with going back through and changing the signs here and there, I'm just going to put parentheses around the whole thing and write the minus out front. So 27 minus 27 cancels. And then 24 minus 0 is 24. And 6 minus 9 is negative 3. So I need to bring down the next term, which in this case was just a 0, and repeat the process. So now I have 24x cubed over 3x squared. That would give you a positive 8. And then x cubed over x squared is x. So I'm just looking at the first term on the inside and the first term on the outside and reducing that fraction. Now when I multiply this out, I get 24x cubed 0x squared plus 8x. We subtract again. So the first part cancels. Negative 3 minus 0 is negative 3. And then 0 minus 8x is negative 8x. And then one more time, we have one last term to bring down. So my first term on the inside is negative 3x squared. My outside first term is positive 3x squared. So all I get is negative 1 when I reduce that fraction. Negative 3x squared over positive 3x squared. So then I get negative 3x squared, 0x, and negative 1. And for our last subtraction, the first term cancels. We get negative 8x. And 0 minus negative 1, that's the same as adding 1. So this piece here, we can no longer divide this anymore because negative 8x is not divisible by 3x squared. So I can't simplify that fraction and get a whole number. So this piece is our remainder. So for writing our final answer, we have our quotient here on top. It's the 9x squared plus 8x minus 1. And then if they ask you to enter the remainder separately, that's the number we had at the bottom when we couldn't do the division anymore. So it's the negative 8x plus 1 on top. And in the denominator of that, it's whatever you were originally dividing by. So the 3x squared plus 1. So that's it for the notes, guys. Thanks for listening.